Slope is steepness. Okay, you think of like a mountain slope, how steep is the mountain? That's what we talk about. So slope is steepness. Okay. It's symbolized by the letter M. Okay. And then we have the slope-intercept form of a line. And we've talked about that a bit. It's y equals mx plus b, where m is our slope and b is our y-intercept. Okay, so that's where it hits the y-axis.
When you say M is the slope?
M is the slope.
And B is your y-intercept, right?
And B is the y-intercept. So B happens where you hit the y-axis, and slope tells you how steep the line is. Okay, so slope, you might have heard, is rise over run, which is the change in y. That triangle can mean triangle, but it also means change. It's the Greek letter delta. Over the change in x, which means we can take the first y and subtract the second y from it. Take the first x and subtract the second x from it.
Okay, what kind of, is that another way of doing slope?
Yeah, so we can look at the rise over the run. This is how far you went up or down versus how far you went over. And delta meaning change, so how much the y's changed over how much the x's changed. And to find that, you subtract the y's and subtract the x's. Now, if we think in terms of slope, well, we always talk about the y part first, up or down. So if you go up or down, and then go over from the direction you read, if you always go this way, up tells you if the slope is positive, down tells you it's negative. As long as you always move from left to right.
So it's like 3 over 4 negative, you go.
If it was, yeah, so if you went like up 3 and then over 2, or down 3 and then over 2.
So when it's a negative,
you're going down first.
right?
And then when it's positive, you're going up first.
But doesn't it matter what the negative is, or it doesn't? On the like on the.
No, it doesn't matter if the negative's on top or bottom. If
Go
they're
down
both
or
negative,
over
it ends up being positive. If either one of them is negative, then the slope is negative.
So okay.
Like the entire thing is negative. So, to find the equation of a line, where we actually have a picture. Okay, our first step is to find the y-intercept. Okay, so that's where we cross the y-axis. So if you look here, I come down the y-axis. Let me just highlight it. Moving down the y-axis and moving, and there I hit. So I kind of went off the line, right there. Yeah. That's my y-intercept, -1. So B equals -1. Okay. So that's this point right here. And then as you move the way you would read. So from left to right. If we move from left to right, we're going up. And you move along this line. So I'm going to start here, and I'm going to move along the line. And I keep going until I find one of those perfect spots where the line crosses through the corners of the squares. That's a perfect point right there.
And then you go down, so if you like.
Well, right now I'm just identifying the point. Okay, so I moved from my y-intercept up the line, I found my next perfect point. Okay, so that's our second step.
You always start at 0?
No, you always start at the y-intercept. always start at the y-intercept, you know, where we hit the y-axis, and then move from left to right along the line until we find that next perfect point, which was right here. Once we found that point, I'm now going to count the steps I'd have to take to get from the y-intercept here to that perfect point there. And I can't go along the line because we're going to like look at this graph paper as a city street map where the lines of the graph paper are roads and in between there are buildings. So I can't walk, you know, up this path through the buildings. I have to take the roads. And I'm not going to take a path like this, you know, to get to where I'm going, right? I'm going to take the easiest, straightest path. So to go from here to here, I'm going to follow that path.
It's 3 over 3.
So I'm going to go up first and then over. It's actually not 3.
So is it 4?
We start here and we go 1, oops, wrong pen. 1, 2, 3, 4.
Is it 4?
So we went up 4,
Over.
and then we go over 1, 2, 3. Because we went up first, I know my slope is positive. If I had to go, you know, down and then over, then it would be negative. But because we went up first, it's positive. So that was our third step, is to count the spaces.
And when your y-intercept is positive, your slope will be negative?
No,
No?
it doesn't matter if your y-intercept is positive or negative. The y-intercept doesn't affect the slope in that way. The y-intercept tells you your starting spot.
Okay, so the line coming that way is positive, right? To the what, second quadrant? Or is that the first one?
Well, here's another thing. Hold on 1 second. If you look at a graph, a positive slope is going to move upward like that, and a negative slope is going to move downward like that.
Okay.
So it doesn't really matter where we start on the y-axis. We could start up here and still be positive, or we could be negative.
Right, so your line, so when the line is going down that way.
That's negative. But if the line was coming down through here,
Right.
we would have had to go down first before we could get over it. Do you see what I mean?
Okay.
So
So if it was, they only give you the slope, and the slope is negative, would the line be negative?
the slope is what is negative or positive. The line is neither negative nor positive. The line is infinite.
Right.
And so the line has positive numbers and negative numbers all in it everywhere, right? It's the slope of the line that would be negative. So if you're positive, because the slope is steepness, right? So that tells you, the number parts tell you how high the line is going. The bigger the number, the more steep the line, the taller it is going straight up and down. And the smaller the number, like the flatter it is. And then the negative or the positive tell you, are we going up as we move from left to right, or are we going down as we move from left to right? So positive, we're going up, negative, we're going down.
Okay.
And then the number tells you, are we going up like a lot, or are we going up just a little bit? Or are we going down a whole lot, or just a little bit? Does that make sense?
Yeah, I mean,
Okay, so we've counted the spaces. The up and down part is the top of our rise. So our rise was that we went up 4. Okay? So we went up 4. That's our rise. And then we went over 3. That's our run. So our slope, in this case, is going to be 4 over 3. Okay, and remember what number goes on the top? Rise has to go over run, and you have to get up before you can go running, right? You have to rise before you can go running. You can't just be running and you're laying on the ground, right? So rise over run. So we have our B and we have our M, and now we have those in space. sorry, those are in the wrong order, but step 4 is we're gonna plug in M and B. So I take this y equals mx plus b, I replace m with a number, and I replace b with a number. So I get y equals m is 4/3, x, and then b is -1. So this equation will tell me every point on this line. Alright, so we're going to use the same process. So first I'm going to move along my y-axis until I find this point here. That's my y-intercept. So b is equal to -1 again. Just by chance, not on purpose. Then, now that I've found my y-intercept, I'm going to move from left to right along this line until I find the next perfect point, which happens right there. Everybody see it? So that's right there. Then I'm going to follow the blocks, and I'm going to go down first and then over to get from point A, my y-intercept, to point B. Okay, so get from point B, my y-intercept, to point C, just my other perfect point. So far, okay? To get from here to here, I go 1, 2, 3, 4 spaces. So I went down 4. Oh, I missed a perfect point, but that's okay, because guess what will happen? I'll get the same number no matter what. And then if I go over, I go 1, 2, so I went over 2.
Or like up 1/1.
No. Up 1 over 1 would put me here. Or you mean up 1, back 1?
Yeah.
Up 1, back 1 would have put me right there. So that wouldn't be perfect either. I could have gone up 2 and back 2, but again,
What would you consider back 2? Would that be negative?
or sorry, back 1. But see, that's what I'm saying. If you always go the direction you read, if you always go from left to right, up and down tell you positive and negative, and then you don't have to worry about anything else. If you start going backwards, then it messes that up. Does that make sense? And then the other thing to keep in mind is if you are going from left to right, if you're going downwards, you're going to end up with a negative number. So if you're doing this and you find a positive number and you look at the picture but it's going down, then you say, okay, I messed up somewhere. I need that to be negative, and you double check yourself. So here we went down 4 over 2. So down 4 is negative over 2, but that'll divide evenly. See, I missed that point right there. I wasn't paying attention. But that's okay, because if I miss one point and I go to the next one, it will just reduce. Do you see what I mean? So my slope in this case is going to be -2. Because if I had caught that first point, I would go down 2 over 1.
Okay, so then
So -2x. Question?
do we give you the -1 or
So we have a horizontal line here, horizontal horizon, flat, and over here we have a vertical line, straight up and down. Now, horizontal and vertical lines always have the same slope. So if I have a horizontal line here, or if it's up here, or anywhere along here, the slope is the same no matter what, because it's horizontal. So in a horizontal line, horizontal, your slope is always 0. And it's 0 because I'm not going up or down at all, right? So my y part is 0. Does that make sense?
it's not doing anything?
not doing anything, it's flat. So it
Even
doesn't,
though it's like -4 on
So
the line,
it's
Yeah.
still acceptable, right?
M is going to be 0.
because it's not moving.
Because it's not going up and down. But so here's what happens whenever you get a horizontal line. Your equation is always going to be y equals some number. And the number y equals is the y-axis number, where it hits the y-axis. Okay? That happens to be here. So in this particular line, we're hitting at -4. So the equation for this line is y equals -4. So if you have a horizontal line, you don't have to do any calculating, you don't have to do any counting. You say, oh, that's flat. Where's it hitting the y-axis? -4. My equation is y equals -4. I'm done. And that's because the m is 0, and 0 times x is 0, and so it just goes away. So all you're left with is the y-intercept. Now, when you have a vertical line, it's a little bit different. The vertical line is going all kinds of up and down, right? So my y is changing all over the place, but I'm not going side to side. So my x is 0. And if remember, our slope is change in y over x, and if I have a 0 down here, is that allowed?
No.
No. So when you have a vertical line, the slope is undefined.
Yeah.
It doesn't exist. It's too steep. It's straight up and down. So we are not allowed to divide by 0, so m in that case is undefined. So these equations, if a horizontal line is y equals a number, what do you think this will be? Yeah, x equals a number. And the number that it equals happens to be where it hits the x-axis, just the same as with the y-axis, except this time we're on the x-axis because we're not moving side to side. So I say, okay, 1, 2, 3. So it's hitting here at 3. So my equation is x equals 3. Yeah.
On any future test,
Uh-huh.
if this question comes up like on an SAT or ACT or whatever, or any test in the future, and it's multiple choice, and one says it could be undefined, and the other one says x equals 3, which one would you put?
It depends on the question they're asking you. If they're asking you what is the slope of this line, then your answer is going to be undefined. If they're asking you what is the equation of this line, it's x equals 3. So it depends on the question that they're asking you. So undefined is the answer to what's the slope. X equals 3 is the answer to what's the equation. Does that help? Okay. Just to recap, any positive slope, your line will go roughly in that kind of direction. And it can be relatively flat. It's still positive, as long as it's moving up as you go from left to right. If you have a negative slope, you're moving down as you go from left to right. If you have a 0 slope, you're flat. If you have an undefined slope, you're straight up and down. Right, so if you're talking about a slope and a rate of change, same idea. So we're going from Columbus, Ohio to Orlando, Florida. Hmm? Okay, cool. Who? Okay. Collinston? Okay. No clue.
It's a football team.
Is it football? Awesome. Cool. I'm good to know that there's a difference between the two, football and baseball and basketball and stuff. So pilot flies from Columbus, Ohio to Orlando, Florida. After half an hour, the plane reaches its cruising altitude and it's 620 miles from Orlando. So I'm going to do like a time distance sort of thing just to kind of organize my information. So we've got half an hour, 620 miles. Half an hour later, so 1 hour. Hmm?
you're considered that.
Not yet, no. Half an hour later, we're 450 miles from Orlando. Whoops, 450, not 550. Okay, and we want to know how far is the plane from Orlando 1.25 hours after the takeoff. So we can figure out our slope using this information. You could graph it, but we don't have to. What I can do is, if I change the t and the d to x and y, time is always x. Always x. Because x is your independent variable and time is independent. We can't affect it. Correct? Not yet, anyway. So time is always x. So this could be x1 and this could be x2. And this could be y1 and this could be y2. And I can use my formula. Okay, and so I have y1 minus y2 over x1 minus x2 I'm going to have to go to I get 170 over negative 0.5, and I don't, two things wrong here. One, the negative's in the denominator, and that's hideous, and we don't like that, so that's bad. And two, there's a decimal inside a fraction. Hideous, gross, disgusting, we don't like that either, that's terrible. This whole thing just looks awful. So I'm not going to use this as a fraction, I'm going to use this as division. So I'm going to take that 170 and I'm going to divide it by negative 0.5, and I'm going to get negative 340. That is my rate of change. So I'm going 340 miles closer to Orlando every hour.
Could you use the same little chart like that for any distance formula though?
Yes, probably. Well, maybe. We'll have to look at them.
Okay.
But
I'll have it.
we're going every hour, we're getting 340 miles closer. So we're taking 340 miles off of our distance every hour. Does that make sense? So,
340 divided by 4, and then add that to 450.
no. Although I can see where you're going with that. I'm going to make it into a formula. But where's B start? We are going to start this.
With 0.25.
No, hold on. Hold on. I'm being confusing. Hold on. Sorry. We have M. This is M. We're looking for this formula. We know M. We don't know B. So we have to find B. I can use X and Y. Either of these X's and Y's to find B. So I'm going to use the X that's a number 1 instead of a 0.5 because that's easier. Okay. So 450 is equal to negative 340 times 1 plus B. Does that make sense so far? So I found M. I had an X and a Y, so I plugged those in. So now I'm going to find B. So I get 450 is equal to negative 340 plus B. So I'm going to add 340 to both sides. So this was the original distance between Columbus and Orlando, 790 miles. Now I can come over here. And plug that in. And then I can solve for any kind of an X. Like if I can say an hour and a quarter, like we're looking looking for, I could say 2 hours, 3 hours, whatever. So I could solve for any amount of time. Or I could use a distance and figure out how long until we're 50 miles from Orlando and find the time that way. So I can, you know, work this problem in any way I want to now that I have the equation. We want to know how far away are we after an hour and a quarter. So I'm going to plug 1.25 in for x.
Why did you plug in that one for?
Here?
Yeah.
Oh, where did it go? This one? Because I needed a y and an x so I could find a b. So I used this one
Okay.
because the 1 is easier to deal with than the 0.5. It was just nicer. So I'm going to come in here and I'm going to plug this in for x. So negative 340 times 1.25 gives me negative 425. So I'm going to be 365 miles away from Orlando at 1.25 hours. So that's the official correct algebra way to do this. The other way we do it is we found our slope is 340. That's 340 every 1 hour. Negative 340. So if I take that negative 340 and I divide it by 4. Because I'm looking for quarter hours, because I have a quarter hour here.
Okay.
So I want to know how much in every quarter hour. So I take that 340 and I divide it by 4, and I'm going to get a negative 85 per quarter hour. Okay, so that tells me how far I go every quarter of an hour. So then I have 1.25. So that's how many quarters of an hour? 5, right? So negative 85 times 5. Oh wait, I don't want to do times 5. I already have times 1. I just need to add another, subtract 85 from that, right? I don't have to do the old multiply.
Is this a different way to do it?
Yeah, this is a different way to do it. So these two take you the official algebra direction, and this is a more kind of arithmetic-y, figured out using logic sort of way. Okay? So we still have to find the slope either way. Now that we know we go negative 85 every quarter of an hour, we are at 450 at 1 hour. Take another 85 from that. And it should still equal exactly what we had before, 365. So that's how far we'd be after 1.25 hours. Questions before you run away?